Examrace. This is the classical mechanics and it's the special theory of relativity. We are here for the mass energy equivalence. We start with the energy relation. So for energy relation, we know one thing. The simple thing is that is the in mechanics, that is the work energy theorem. So we can say this is the relativistic mechanics. In that we have work energy theorem. Okay, so what is work energy theorem? It's K final minus K initial is equals to work done or change in work done. Okay, so let this be the change in work done. Now, what is K final? It is half M V final square K initial half M V initial square, and work done I write this as a, what is work done? Work done is force into displacement, and this displacement is from initial position to final position. But according to the Newton's second law, what is the force? Force is rate of change of momentum. So just write this as a rate of change of momentum. Okay, so it's from initial to finals dp by dt into dr. Fine. Now this is a rate of change of momentum, but we are here for relativistic mechanics, means now we move from pre-relativistic mechanics to relativistic mechanics. Okay, so for relativistic mechanics, there is a different way. Means I want to change one thing only. Means that what is rate of change of momentum with respect to dr, or integration with respect to dr. Then it is nothing but integration of v dp. Okay, v dp. Why v dp? Because dr over dt is v, and there is a change in momentum. When we talk about the relativistic mechanics, then we have already learned that when a simple particle or a body moves with the speed, and that speed is approaching the speed of light, then there is a mass defect, or there is a change in mass, and due to that change in mass, the mass does not constant. So the integration, that is what we can integrate it using the m and v both as a variable. Not in some cases we have used, means in pre-relativistic mechanics we have used the concept of the constant mass. Okay, but here the mass is not constant. So we approaches to the system that v dot dp. Now remember one thing, that this dp is depend upon the product of mass and velocity, because it's a momentum. Now before moving to next step, just partial derivate the product of momentum and velocity. Okay, so it's going to be p dv plus v dp. Now this term is already in the integration, so can I write v dp as d of derivative of p into v minus p dv? That's simple one. Clear? Just put the values. So just put the value. Simply put these values. So what we got? We got derivative of p into v minus integral p dv. Fine. And this is very first term is very easy to solve. This is simple p v. Clear? Now come to this. What is p dv? P is what? mv. Simple, mv. So it's mv dv. So we remain with pv minus mv dv. Here also we can put the value of p. So it's going to be the m v dot v dot v. So this v dot v becomes v square. Clear? And this is m v dv. Now just don't integrate simply, because here mass is varying and we will see how the mass is varying. Okay, as we already discussed that the mass m is varying, so just replace the value of m as m naught over root of 1 minus v square over c square. If we do this, so we got m naught v square over root of 1 minus v square over c square, then minus m naught over root of 1 minus v square over c square into v dv. Just we have to integrate the second term, that is v over root of 1 minus v square over c square dv. For this, let 1 minus v square over c square is equals to x, and if I solve this is minus 2v dv over c square equals to dx, and from here what is v dv? It is minus c square by 2 dx. Just replace the value. So if I do so, it's minus c square by 2 is a constant and we remain with the dx over root of x. Clear? And if I solve this, I got the value c square into root of x. Just put the value of root of x, so it's going to be the minus c square root of 1 minus v square over c square. This is what we got, plus c for the constant, that is indefinite constant. Means what the value of this term is simply this one, and let this be the first equation, this be the second equation. If I put the second in one, okay, so what I got, this is what the simple integration we got. Now just take LCM. LCM is root of 1 minus v square over c square, so it becomes m naught plus m naught c square times 1 minus v square over c square. And if I solve this also v square here, okay, so this is v square. Now if I solve this, I got multiply c square with this bracket. So first is going to be, after cancelling the minus mv square with the plus m naught v square, I got m naught c square over root of 1 minus v square over c square. But we have decided that this is what the m only. Clear? So integration of dp by dt of dr is this one. Clear? Now